Hello everyone, welcome to Digital Communication Tutorials. In this video, I'm going to take up the 7th numerical on baseband shaping for data transmission. Please note, this is a numerical on modified duobinary signaling scheme. Let me read out the question here. Consider a binary sequence BK equal to 010, 111, 00. Part A of the question says, construct the modified duobinary coder output and the corresponding receiver output without a precoder. Part B of the question says, suppose that owing to error during transmission, the level at the receiver input produced by the second digit is reduced to 0. Construct the new receiver output and conclude on the error propagation in the system. Part C of the question says, repeat part A and part B with precoder attached. Assume B minus 2 equal to B minus 1 equal to 0. Right. Let us start with the solution part. Let me rewrite the given binary sequence here. Let me now start with part A of the question, which is to construct the modified duobinary coder output and the corresponding receiver output when there is no precoder attached. I'm going to start with the transmitter part first. Here, I'll be constructing a small table to illustrate the encoding and decoding. I'll specify B minus 2 and B minus 1 in these two columns. Right, let me start. I'll start by writing the input binary sequence BK. This is given as 0, 1, 0, 1, 1, 1, 0, 0. The next step is to write the polar form of this binary sequence BK. Here, wherever there is a 0, you put a minus 1, and wherever there is a 1, you put plus 1. This is the polar representation of the input binary sequence. The next step is to write the encoded sequence CK. And here, to generate the encoded sequence CK, I'll be using the expression CK is equal to BK minus BK minus 2. Now, since I require BK minus 2, I'll be now using the initial bits B minus 2 and B minus 1, which are given as 0, 0. So, in the polar form, this will be minus 1 and minus 1. Let me now start the computation. In this position, it is BK minus BK minus 2, that is minus 1 minus of minus 1, so it would be 0. Here, it is plus 1 minus of minus 1, which is this, so it would be plus 2. Here, it would be minus 1 minus of minus 1, it is 0. Next one is also 0. Then we have a plus 2, then we have a 0. Then we have a minus 2 and minus 2. This is the encoded sequence. Please note, the same sequence will be transmitted by the system. So, therefore, I will write the transmitted sequence as, right, this is the transmitted sequence. Let me now move on to the receiver part when there is no transmission error. I'm going to once again construct a small table here. I'll start with the received sequence. Under the assumption of no transmission error, this will be exactly equal to the transmitted sequence. I'm going to use B minus 2 and B minus 1 here, which is 0, 0. Now, come back to the transmitter part and look at the equation that we have used to generate the sequence. This is CK is equal to BK plus BK minus 2. Therefore, at the receiver part, if I want an estimate of BK, I will rearrange this equation. So, I will get BK cap equal to CK plus BK minus 2. However, please note, when I use this equation, I will obtain the decoded sequence in the polar form. So, I will write here polar form of bk cap is, so equation is bk cap is equal to ck plus bk minus 2. Let me start the operation now. Before that, I will write the polar form of the initial bits. This would be -1 and -1. So, at this point, it is ck, which is 0, plus bk minus 2, which is -1. So, this would be -1. At this point, this is +2 plus -1, which is here. So, this is +1. At this point, it is 0 plus -1. So, it would be -1. Here, we will get a +1. The next one is also +1. The next one is again +1. Here, we will get -1. And the last digit is also -1. This is the polar form of the decoded sequence bk cap. Therefore, the decoded sequence is given by, here wherever there is a -1 you put a 0, and wherever there is +1 you put a 1. This is our decoded sequence. Let me write it here. Right. Let us now check whether the encoding and decoding has been successfully done. And to do that, we compare the decoded sequence with the original input binary sequence. The original input binary sequence is 010, 111, 00, and the decoded sequence is also 010, 111, 00. Therefore, the encoding and decoding operations have been successfully implemented. This is the solution for part A of the question. Let us now move on to part B. Part B of the question says, suppose that owing to error during transmission, the level at the receiver input produced by the second digit is reduced to 0. Construct the new receiver output and conclude on the error propagation in the system. So, here I will write receiver with propagation error. We are told that the second received digit is an error, and we are told this is actually 0. So, let me now rewrite the received sequence. This is, please come back to the transmitted part and note down the second digit is +2, but due to transmission error it has been changed as 0. So, the new received sequence is 0 0 0 0 plus 2 0 minus 2 minus 2. This is our new received sequence. Okay, now I am going to once again construct the same table for the receiver. I will start by writing the received sequence. It is 0 0 0 0 plus 2 0 minus 2 minus 2. I will once again be using b minus 2 and b minus 1 here. As in the previous receiver, we will now compute the polar form of bk. I will be using the equation bk cap equals ck plus bk minus 2. We know that b minus 2 and b minus 1 are 0 0. So, their polar form would be -1 and -1. Let me now start the computation. At this point, this is ck, which is 0, plus bk minus 2, which is -1. So, this would be -1. At this point, this is ck 0 plus bk minus 2, which is once again -1, which is once again -1. At this point, it would be 0 plus -1, so it is -1 again. At this point, it is 0 plus -1, once again -1. At this point, it is +2 plus -1, which is +1. At this point it is 0 plus minus 1, therefore it is minus 1. Here it is minus 2 plus plus 1, so minus 1. And lastly here it is minus 2 plus minus 1, which is minus 3. This is the polar form of the decoded sequence bk cap. However, you should note there is a new value here which is minus 3, which does not fit into the polar form amplitude value. I will now continue the decoding operation and write down the decoded binary sequence bk cap. To do that, all we need to do is wherever there is a minus 1, you put a 0. Wherever there is a plus 1, you put symbol 1. However, you should note there is a new amplitude level which is minus 3 and it does not fit into the polar form amplitude. So, I will simply put an X here. Let us now analyze the error. We were told that the second digit is an error. Therefore, the decoded binary bit at the second digit is also an error. Coming back to the equation for decoding, please note bk cap is equal to ck plus bk minus 2. That means that if bk cap has to be correctly decoded, then bk minus 2 should also be correctly decoded. Now, coming back to this position, which is position 2, we know that it is an error. So, quite obviously, you can expect B4 also to be an error, and B6 will also be an error. Lastly, B8 is an error as well. Right? So, what do we conclude from this? Since the decoding of the current bit bk cap depends on the correctness of decoding of bk minus 2 cap, any error introduced into the system will propagate in the system and affects the decoding of bits that are spaced 2 TB seconds apart. That would be our conclusion. Right. That completes part B of the numerical. Let us now go and see what is part C of the question. Part C of the question says, repeat part A and part B with a precoder attached to the modified duobinary system. Right. Let me now start with the modified duobinary with the precoder attached. I will once again demonstrate the transmitter part. I am going to once again start constructing a simple table here. Let me write the input binary sequence first. It is 0 1 0 1 1 1 0 0. We have been told B minus 2 and B minus 1 are 0 0. The next step when a precoder is attached is to generate the precoded sequence AK. And the equation for this is AK is equal to BK modulo 2 addition AK minus 2. Please note this is a modulo 2 addition. Since we do not have AK minus 1 and AK minus 2, I am going to retain B minus 2 and B minus 1 as AK minus 2 and AK minus 1. Right. Let us now start performing the operation. At this point, it is 0 plus AK minus 2, which is also 0, so it is 0. At this point, it is 1 plus 0, it is 1. This point, it is 0 plus 0, it is 0. This point, it is 1 plus 1 modulo 2 addition 0. At this point, it is 1 plus 0, it is 1. Similarly, we will get here 1, 1 and 1. This is the pre-coded sequence. The next step is to write the polar form of the pre-coded sequence AK. And for this, wherever there is a 0, I put a minus 1. And wherever there is a 1, I put a plus 1. I will do the same for the initial bits which are 0 0. The last step here is to write the encoded sequence Ck, and for this I will be using the equation Ck equals Ak minus Ak minus 2. Okay, let me start the operation here. So at this point it is minus 1, minus of minus 1, it is 0. At this point it is plus 1, minus of minus 1, it is plus 2. At this point it is minus 1, minus of minus 1, which is 0. Here it is minus 1, minus of plus 1, so it is minus 2. At this point it is plus 2. This point it is plus 2. Here it is 0. And here it is 0. Therefore, the transmitted sequence is given by, right, this is our new transmitted sequence. Let us now move on to the receiver part without error. I am going to construct a table once again. I will write the received sequence here. Right. Now, please note, when a precoder is attached, we will not be doing any computations for decoding the binary sequence. Instead, we will be using a decision rule which is given by Bk cap is equal to symbol 0 if the magnitude of Ck is less than 1, symbol 1 if the magnitude of Ck is greater than 1. This will be the decision rule. Therefore, the decoded binary sequence is given by, here wherever the magnitude of Ck is less than 1, you put a 0, and wherever the magnitude of Ck is greater than 1, you put a 1. Therefore, the new decoded sequence is right. To verify whether the encoding and decoding was successful, we will compare the decoded sequence with the input binary sequence, and we find that they are one and the same, which indicates the operation was successful. Lastly, I am going to once again demonstrate the receiver, but with the transmission error. We are told the error is in the second received digit. Let me write the table once again. Right. I am going to fill up the values here. Please note the second digit is supposed to be an error. Therefore, the new received sequence is 0, 0, 0, minus 2, plus 2, plus 2, 0, 0. So, let us now perform the decoding operation using the decision rule that is mentioned here. Whenever the magnitude of Ck is less than 1, you put a symbol 0. And whenever the magnitude of Ck is greater than 1, you put a symbol 1. Let us now analyze the error. We were told the second received digit is an error. Therefore, quite obviously, the second decoded digit will also be an error. Now, coming to the remaining bits, you will find that all of the remaining bits are correctly decoded. Therefore, the conclusion now should be, with the precoder attached, the decoding error is restricted to the location of the transmission error and does not affect the decoding of the remaining bits. Right, that is the solution for this numerical. Well, if you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.